Hey everyone, welcome. Today we're going to dive into a really fundamental tool in any C++ programmer's toolkit, the struct. It's a simple but super powerful way to organize your data and write much cleaner, more intuitive code. So let's get right into it. All right, so let's kick things off with a classic problem, right? Imagine you're building a system to track student records. You've got an ID, a name, a GPA. How are you supposed to keep all of that related information together for one student, let alone a whole class, without it becoming a complete and total mess? And this is exactly what I'm talking about. On the left, you see that chaos, just a tangled mess of separate variables you have to keep track of. But on the right, that's our goal. One single, clean container that holds everything related. That is the elegance we're aiming for. Okay, so let's really dig into this problem with data and explore why juggling all those individual variables gets so complicated so fast. You know, there's a technical term for this, and it's heterogeneous data. It sounds a bit fancy, but all it really means is a collection of data with different types. And a student record is the perfect example, isn't it? You've got an integer for the ID, a string for the name, and a float for the GPA, all belonging to one single person. This is the exact problem we need a good solution for. And that brings us to the solution, the C++ struct. I want you to think of a struct as your own personal tool for designing a brand new, custom data type. The best part? It's built right into C++. No special libraries or anything needed, and it's made specifically to handle this kind of mixed data. Now, what's so great about this is just how simple the syntax is. You use the struct keyword, you give your new type a name, in this case, student, and then inside those curly braces, you just list out all the member variables it's going to hold. That's it. You've literally just created a blueprint for data. And this is a really crucial point. Defining a struct is just like drawing up the architectural plans for a house. That blueprint itself isn't a house, right? It's just the design for a house. In the exact same way, this struct definition doesn't actually store any student data. It just defines what a student data type is supposed to look like. Okay, we've got our blueprint, so now for the fun part, let's see how we go from that blueprint to actually building something and using our custom type. It really boils down to 3 simple steps. First, you define the blueprint. We just did that. Second, you declare a variable of that new type. You can think of this as creating an actual object. And third, you access the individual pieces of data inside it using the good old dot operator. And this right here is a perfect example of that third step in action. We declare a variable, s1, of our new student type. Then, using that dot, we can directly get to its members and assign them values, s1.id, s1.name, s1.gpa. See how each member just acts like a regular variable, but now it's all neatly organized inside our s1 object. Now here's a quick but super important distinction. When you have the struct object directly, like our s1, you use the dot operator. But, as you probably know, C++ has pointers, variables that just store a memory address. So, when you have a pointer to a struct, you use the arrow operator instead. Same goal, different syntax. That's really all it is. Okay, you've got the basics down, so let's level things up a bit, shall we? Let's see how structs can act as building blocks for even more complex collections of data. So what if you need to store records for an entire class, not just one student? Well, it's actually incredibly simple. You can just create an array, or even better, a vector of your custom student type. With just one line of code, like vector student class roster, you now have a dynamic list that's ready to hold all of your student objects. So cool. Oh, but it gets even better. You can actually nest structs inside other structs for even more fine-grained organization. Check this out. We've created a separate name struct, and then we just use that name struct as a member inside our student struct. This is just fantastic for keeping your data structures clean, logical, and really easy to read. And for ultimate flexibility, C++ gives us something called template structs. Think of it like a master blueprint. You can define a generic struct, like a pair of items, using a placeholder for the type instead of something specific like int. Then, later on, when you actually create an object from it, you can specify if that pair should hold integers, or floats, or even other structs. It's an incredibly powerful way to write reusable code. Okay, so let's zoom out for a second and put this all together. Let's talk about why this actually matters, because it all comes down to the power of clean, organized code. So what are the big takeaways? First, structs let you group related, mixed data into a single logical unit. This, in turn, makes your code incredibly clean and way easier to understand. They act as the perfect building blocks for more complex data collections, and, maybe most importantly, they're a fantastic stepping stone to the powerful concepts of object-oriented programming. But there is one really important rule you have to remember. You can't just, say, print out a whole struct at once or compare two of them with a greater than sign. It just doesn't work that way. Out of the box, the only operation that works on a whole struct object is assignment, basically copying one into another. For everything else, you have to work with the members one at a time. You see, by really getting a handle on structs, you've leveled up as a programmer. You're not just using the data types C++ gives you anymore, you're actually designing your own. You have the blueprint to model pretty much anything you can imagine, from a character in a video game to a complex financial record. So, really, the only question left is, what are you going to build?